Hello and welcome back to our next live class on friction. So in this class we are going to talk about more about friction. I hope in the first chapter you must have already studied a little bit of introduction about friction, what friction is. So let's get deep inside this concept of friction and understand as to what is it. So now let's say you have a ball as you see right in front of you. So suppose if we apply a force of, let's say we apply a force here, and the amount of force that we apply is 10 newtons. So when we apply a force on this ball, the ball actually moves to a certain distance, and you will see that whether you try to stop the ball or not, the ball on its own after some time will come to a stop. If you try to stop the ball, it will come to a halt. But even if you don't try to stop the ball stops on its own after traveling certain distance. Now, what do you think is exactly the reason behind stopping, the halting of the ball on its own? That is because the ball is actually in contact with the ground below. Okay, so as long as the ball remains in contact with the ground will continuously be providing a resistance to the motion of the ball. That is, the ground will apply an opposite force to the motion of the ball. If the ball's motion is in this direction, then the opposite force will be in this direction. So this force will always try to stop the ball. Correct? So this opposite force which is acting on the ball, which is provided by the ground, is known as frictional force or friction. Okay? So this friction will always try to stop the ball. Now, again, look at this picture which is right, the person who is actually walking here on your left, as you see. So he's able to walk very comfortably on the road. But why do you think that the person, the boy, he actually is falling once he steps on the banana peel, on the banana cover? He's actually falling easily. What is the reason? Why is that the man who is walking on the road is able to walk very comfortably? However, the boy, once he steps on the banana peel actually makes him slip down on the ground. So what is the difference? Which means that banana peel must be providing some kind of extra force. Okay, banana peel is making the person's motion quicker, much faster, and that's why he's able to fall easily. So what is that which is making what is that force which the banana peel is providing? So now let's understand this also. Now, the boy, once he steps on the banana cover is actually much more smoother surface as compared to a road on which the other man is walking, right? So this banana cover, because it is smooth, so what will happen is the friction which is provided because of this banana cover will be much lesser as compared to the friction provided by the road. Because the cover makes it, the surface is very smooth, that's why the person actually slips easily. However, if you compare a road, the road is a much rough surface. So on a rough surface, you have more restrictions, you have more hurdles, and because the surface is rough, so you will have a problem in walking smoothly. You can't skate on the road. So what is that which is different about the road and about the banana peel? Is that the road is a rough surface and the banana cover is a smooth surface. So whenever the surface is rough, you have more friction. Whenever the surface is smooth, you have less friction. Okay? So here when the surface is rough, you will have friction. Friction will be more, okay, in this case. But in the other case, when the boy steps on the banana cover, here the friction is less. Because the friction is less, his motion will be more. Okay, in the first case, because the friction is more, So the motion of a person is going to be less. So understand that motion and friction are inversely proportional to each other. I repeat, motion and friction are inversely proportional to each other. If you've not understood this, you will understand in the next examples that we are going to talk about. Now suppose look at this boy. He's sitting on a swing and he's trying to enjoy the swing. Now when he sits on the swing, what happens is, now in the first go, the swings comes, in the front direction, forward, and then the swing also goes back. So now when the swing comes front, it automatically goes back, and then front, and that goes back. So it actually moves to and fro, right? And if no one is pushing the boy, after some time the speed of the swing is going to reduce on its own, and the swing will come to a halt on its own. So again, my question is, why does the swing comes to a halt? That is because, understand that when the swing is coming in the forward direction, this is the motion of the swing, okay? In the front, this is the motion of the swing. Now when the swing is coming in front, I told you that there is always an opposite force which is acting opposite to the direction of the motion of the object. So if the motion is in this direction, the frictional force is in the opposite direction. So when the swings come in front, in forward direction, there's a force which is pushing it back, okay? Again, same way, when the swing goes back, so if this is the motion of the swing while going back, then there is a force which is known as frictional force, which is acting in the forward direction. So when the swing goes back, there is a force which is acting in the opposite direction. So again, in the backward direction also, there'll be a force pushing the swing in the front direction, and in the forward direction also, there is a force which is trying to push the swing in the backward direction. So in both the direction, every time the swing is traveling forward and backward, there is force which is trying to stop the swing. That force is known as frictional force, okay? Now let's also understand where all does a frictional force act. So this example we have already studied. When a ball moves ahead continuously, when is in touch with the ground, what is happening is the ground is providing an opposite force which is opposite to the direction of the motion of the ball, okay? Because of that opposing force, because of this resistive force, the ball comes to a halt on its own. That force is known as resistance. So where all does this resistance acts, where all does this friction acts? On the ground, whenever the object is in touch with the ground, and also whenever any object is actually traveling through air or through liquid, there is always an opposite force, okay? For this force to be available, you need two objects to be in touch with each other. For example, in this case, the ball is in touch with the ground. Suppose when the boy was swinging, then in that case, the body of the boy was in touch with the air. So there it is the air resistance, it is the air friction. In this case, it is the ground friction. In the case of this ball, it is known as ground friction. So these words you may like to write down. So this is also called as ground friction, okay? Then you have air friction. You also have air friction, okay? So air friction is provided by air, ground friction is provided by ground, liquid friction is also there, which is provided by liquid. So any force which acts opposite to the direction of the motion of the object is called as friction, okay? Now, so this we have already discussed again. So again, if I'm to put a question to you, let's say, how do we walk? How are we able to walk? It is the friction only which helps us to walk. How? It is like this. Now, what we are doing while we are walking is that when we walk, we try and push the ground behind. we try and push the ground behind, and that's why the ground in turn pushes us, in the forward direction, right? We push the ground behind, the ground push us, in the forward direction. So it's always, what equal and opposite action and reaction. So which you will study in probably your next class. So it is the friction which helps us to walk. Okay. Next is, now that we've talked about friction so much, what is the definition of friction? So the definition of friction is a resistance to the motion of one object moving relative to another. What do you mean by one object moving relative to another? Which means one object is moving with respect to the other. So here, this is the first object, okay, and the second is the ground. So first object is in touch with the second object. So first object is moving with respect to the other object, okay? And we may say that it is the enemy of the motion. It is the enemy of the motion. So if the motion is in this direction, if this is the motion, friction will always be in this direction. If the motion is in this direction, then the friction will be in this direction. Okay, so it is always trying to stop the motion. Okay. It always acts in the opposite direction, is what we have just studied. Now, what are the factors on which friction depends? Means what factors will change friction? When will friction be more? When will friction be less? What are these factors which will contribute to change in the friction? Okay. Now look at this picture as you see on the screen. Here you have two, boys, and they are trying to, slide down two types of surfaces. The one on the left is trying to slide over the, the snow, and the other one is just trying to slide down over a normal grass surface. So which one do you think is going to come down first? Is the boy who is trying to slide on the snow, is he going to slide down first? He's using some sledge. Or the other boy who's trying to slide, over the surface of the grass is going to come down first? The answer is very obvious. The student or the boy who's trying to slide down over snow is going to, slide down and come down first, is because his speed is faster. Automatically it will be faster because he is actually he's sliding down on a very, very smooth surface. What makes his speed faster? It is the kind of surface on which he's sliding. He's sliding on snow. It's a smooth surface as compared to the surface of the grass. Okay, so now understand, it is the nature of the surface which is going to decide about the friction. Understand that if the surface is smooth, then the friction is going to be very less. If the surface is smooth, the friction is going to be very less. In this case, if the surface is rough, okay, then the friction is going to be very high, very large, okay? So the lesser the friction, the more the motion. This also is very important. The lesser the friction, the more the motion. Okay, in the second case, if the friction is very high, very large, then the motion will be restricted. The movement will be restricted. So what is one point that you can take back from this slide is that friction and more movement or motion are inversely proportional to each other. If the friction is more, the movement of the body is going to be less. If the friction is going to be less, then the movement if the movement of the body is going to be more. So they are inversely proportional to each other. Okay, and smooth surface will provide less friction. Okay, because it provides less friction, the movement is going to be more. So that is about the nature of the surface. Okay, the next one is again the nature of the surface. Now this is a second example that I have taken. Now just consider that you have here two two pics as you see here. First one is the boy on the left. He's trying to push the box on a very smooth surface, and the second one is trying to push the box on a rough surface. Now, what makes a surface smooth? Let's say you pour some soap water on the floor, or you pour some oil on the floor, so the floor becomes smooth as compared to a normal rough surface. So let's say you have a layer of the oil here or soap here. Now, which one of these two boys will be able to move the box quickly? It is the boy who's trying to push the box on a soap water or over an oily surface will be able to push the object faster. Now, why is it so? Again, because in the first case, the surface is smooth. When the surface is smooth, the friction is going to be less. When the friction is going to be less, then the movement of the object is going to be more. Okay, I hope you can understand these arrows. Down arrow means less and up arrow means large or high or more. Okay, in the second case, because the surface is rough, so the friction will be very large. When the friction is large, the movement of the object or of the body is going to be very, very less or very small. So again, understand that friction and motion are inversely proportional to each other. Okay, that's why we see that on a smooth surface you will be able to move faster. Okay. Now, so first is the nature of the surface that we talked about. Next one is the weight of the object. How does the weight of the object actually decide about friction? Now imagine that you have a weight which is 50 kgs and another weight is 5 kgs. So you have two weights and you're trying to push both the weights. So which weight do you think you will be able to push quickly or at a much faster speed? Obviously, the weight which is less you will be able to push it quickly as compared to the weight which is more. So understand that if the weight is going to be more, then friction is also going to be more. If the friction is going to be more, then the movement of the object is going to be less. Okay? Now look at what happens in the second case. If the weight is going to be less, then the friction is also going to be less. If the friction is going to be less, then the movement of the body is going to be more. Okay? So more weight, that means more friction. More friction means less movement of the body. On the other hand, if the weight is less, which means that the friction is also going to be less. If the friction is going to be less, then the movement of the object is going to be, large or very high. Okay? So I hope you can understand how the weight matters. Okay. Now. So what happens if, I'm sure that after understanding the smooth surface and the weight of the object, you can answer this question. What happens when we apply soap to our hands? Why is that we are able to move our hands easily, or our hands actually slip in between each other? Why does our hands slip easily? It's because when we have soap, it's a soapy surface, right? We have soap in between our hands. So the soap makes our hands very, very smooth, or the surface very smooth. So because the surface is smooth, the friction is going to be less here. If the friction is going to be less here, the movement is going to be more. So that means our hands will be able to move our hands much more easily against each other. We will be able to rub our hands much more easily as compared to when our hands are dry. Okay? So these are the points to remember from what we learned in this, in this class. If the surface is smooth, then friction will be less. If the surface is rough, then friction will be more. However, if the object is heavy, then friction will be more. If the object is light, then friction will be less. So with that, I hope that you have understood what is fiction, how and what are the various factors of fiction, how can we, how in which ways fiction increases, in which ways the fiction is less, and also the relationship between fiction and movement. So in the next class, we will study about what are the methods of increasing fiction and what are the methods of reducing fiction. So see you in the next class. Thank you so much.